Show that the vector A and the position vector B are equal. Vector A is formed from tail to head between the points P at coordinate 1, 2 and Q at coordinate 6, 4. Vector B is the position vector 5, 2. So in order to show that vector A is equal to the position vector B, we have to show that their components are equal. Remember, two vectors are equal if and only if their components are equal. So to help me show this, I'm going to graph both vectors A and B on the same coordinate system. We're going to look at this graphically, and then we'll look at it algebraically. So in our coordinate system, well, I'm going to slide this picture to the right a little bit. Let me switch to my pencil for this. And let's go ahead and begin sketching now. So I see, I'm going to start off with my x-axis. It looks like my x-axis will at least need 5 units in the x direction. So I'll go over several divisions. Here's my x-axis. Every 5 divisions will correspond to 1 unit on my scale. And so I will indicate that in my sketch. Actually, I think we need to go out to 6 units along the x-axis because I see that the point Q is at coordinate 6, 4. So I'm going to just redraw my x-axis to give myself more space to add things to the same graph. So here's my x. We're going out at least 6 units. Now my y-axis, I see my y-axis, since the point Q has a coordinate 6, 4, I know I need to go up at least 4 units on my y-axis. So I will come up here and we have 1, 2, 3, and 4. I'm thinking my little problem statement is going to get in my way a little bit, so I'm going to move that out of the way just a little bit so I don't have to worry about it. Okay, so let's look at vector A. Vector A is formed between points P and Q. Point P is at coordinate 1, 2, so I will label that here. Oops, need to switch to my pen. So 1, 2 is the point right here. That is point P. And then point Q is at the point 6, 4. So I go 6 units on the x-axis, 4 units on the y-axis. So here is point Q. I will say point Q is at 6, 4. Let's connect these 2 points with a vector arrow. So this is my vector A, which is connecting the 2 points starting from P and ending at Q. Now, if we look at this from our graph, we could see that we could just count how many divisions we are along the x-axis for our vector A. So what I see here is the x component of vector A goes out, looks like 5 divisions, 1, 2, 3, 4, 5. So the x component of vector A is 5 units along the x-axis. And let's look at the y component of vector A. The y component of vector A goes up 2 units along the y-axis. So we could say the x component of vector A has a magnitude of 5 units pointing along the x-axis. The y component of vector A has a magnitude of 2 units parallel to the y-axis. So we could write vector A in terms of its components as 5, 2. And you know what? The components of vector A matches the components of vector B, which also has components of 5, 2. So these vectors are equal. Remember, two vectors are equal if and only if their components are equal. So here we see that the x component of vector A is equal to the x component of vector B. The y component of vector A is equal to the y component of vector B. Now let's sketch vector B just for good measure. So we know vector B has components 5, 2. So when we start off on the x-axis, or at the origin rather, let's start at the origin. We are going to take vector B 5 units along the x-axis, and then up 2 units along the y-axis, and this is vector B. Now, if vector A and B are truly equivalent, then we should be able to superimpose them and have a vector that lying on top of the other. So when I move vector A, when I translate it to be starting at the origin, notice how vector A matches vector B. Those two vectors are equal because their components are equal.